Welcome to a journey through the strangest corners of our universe. From disappearing stars to cosmic giants, today we uncover 100 bizarre and fascinating phenomena you won't believe exist. Facts that stretch the imagination and reveal the secrets of the cosmos. Chapter 1. The universe is stranger than fiction. Imagine a star that spins so fast it's nearly breaking apart. Known as a pulsar, it rotates hundreds of times per second, emitting beams of radiation like a cosmic lighthouse. Scientists use these beams to map space with extreme precision. It's fascinating that a tiny, dense sphere of matter can serve as both a timekeeper and a probe into the mysteries of the cosmos. Space really plays by its own rules. Chapter 2. Some galaxies collide, creating spectacular cosmic fireworks. When two galaxies meet, stars rarely crash directly, but the gravitational chaos flings clouds of gas and dust everywhere. These interactions trigger bursts of star formation, lighting up regions that were once dark. The Milky Way itself is on a slow collision course with Andromeda, a future galactic smash-up. Imagine the skies glowing with newborn stars for millions of years. Science calls this a starburst, and its beauty sculpted by gravity. Chapter 3. Black holes aren't just voids. They are engines of power. Supermassive black holes, millions or even billions of times heavier than our sun, sit in galactic centers. When matter falls in, it heats up and emits intense X-rays, sometimes creating jets that stretch thousands of light years. Scientists can measure these jets to study magnetic fields and galaxy evolution. The sheer energy output rivals entire galaxies, proving that even in darkness, the universe has. Chapter 4. Rogue planets wander alone through space. Unlike Earth, they don't orbit a star, drifting silently in the cosmic dark. Some are as massive as Jupiter, yet cold and invisible except through gravitational effects or microlensing. Astronomers estimate there could be billions of these loners in our galaxy alone. Their existence challenges the idea that planets always need a sun. Picture an eternal night. A planet traveling for eons without a single sunrise. Lonely but mysterious. Chapter 5. Neutron stars are tiny but extreme. Just 20 kilometers across, they pack more mass than our sun. A sugar cube-sized piece would weigh billions of tons. Their magnetic fields are so strong they could erase your credit cards from across Earth. These stars can quake, sending bursts of radiation detectable across millions of light years. The physics inside is unlike anything on Earth, where matter behaves in ways that Chapter 6. Quasars shine brighter than entire galaxies. Powered by supermassive black holes, they devour matter at furious rates, creating light that travels billions of light years. The light we see today left when the universe was young, letting astronomers peer back in time. Quasars act like cosmic lighthouses, guiding us through space and history simultaneously. Their brilliance challenges imagination. A single point in the sky can outshine 100 billion stars combined, a reminder of the universe's immense energy. Chapter 7. Cosmic voids are enormous, almost empty regions. Some span hundreds of millions of light years, with barely any galaxies inside. Scientists study these voids to understand dark energy and the universe's expansion. Despite their emptiness, they shape cosmic structure, pushing matter into filaments that form the cosmic web. It's fascinating that nothingness can influence everything. These voids are like giant bubbles in space, proving that absence can be just as powerful as presence. Chapter 8, Gamma ray bursts are the universe's fireworks. They release more energy in seconds than our sun will in its entire lifetime. Triggered by collapsing massive stars or merging neutron stars, they shine across billions of light years. Astronomers detect them with satellites, learning about early galaxies and extreme physics. The bursts can sterilize planets in nearby regions, showing the universe isn't always gentle. These fleeting explosions are reminders that cosmic violence can be beautiful, terrifying, and awe-inspiring. Chapter 9, Exoplanets come in bizarre forms. Some are hot Jupiters, gas giants orbiting so close to their stars that they reach thousands of degrees. Others are diamond planets, theorized to have carbon-rich cores. Planets can have extreme winds, molten surfaces, or even rain glass sideways. The diversity defies imagination, proving that the solar system is far from typical. Each discovery challenges how we define worlds, expanding our understanding of what a planet can truly be. Chapter 10. Some stars live fast and die young. Massive stars burn fuel rapidly, exploding as supernova after just millions of years. These explosions forge elements like gold and uranium, spreading them across galaxies. The debris becomes the building blocks for planets and life. Our very atoms were once part of ancient supernova. In a sense, we are stardust experiencing the universe. This cycle of creation and destruction shows that even the most violent events have a purpose in the cosmic story. Chapter 11. Some stars wobble mysteriously. Binary systems can cause strange orbits, but some stars seem to dim and brighten without any companion. Tabby's star became famous for this unusual flickering. Scientists propose dust clouds, comets, or even massive alien megastructures as explanations, though natural causes are most likely. The irregular patterns challenge astronomers to rethink how light interacts with cosmic material. It's a reminder that the universe can surprise us, showing phenomena that don't fit neatly into existing theories. Chapter 12. The universe hosts massive cosmic filaments. These thread-like structures connect galaxy clusters across millions of light years. Dark matter acts as scaffolding, pulling visible matter along. They shape the cosmic web, dictating where galaxies form and where voids expand. Observing these filaments helps scientists map unseen matter and understand large-scale cosmic evolution. Though invisible to the naked eye, they are the universe's backbone, an intricate network that holds everything together in a delicate gravitational dance. Chapter 13. White dwarfs are stars in retirement. After burning all their fuel, they collapse into dense, dim remnants. Some spin rapidly or crystallize, forming solid cores of oxygen and carbon. Over billions of years, they slowly cool, fading into invisibility. Despite their small size, they contain mass comparable to the Sun. Studying them provides insight into stellar life cycles, helping scientists like a universal ruler, mapping the scale of galaxies and the universe. Without them, our understanding of the universe's size would be far less accurate. These stars are living metronomes, bridging imagination and calculation. Even subtle changes in light can unlock secrets billions of light years away, proving that the cosmos communicates in patterns. Chapter 15. Black hole mergers shake the cosmos. When two black holes spiral into each other, they release gravitational waves, ripples in space-time detected on Earth. This invisible vibration travels across billions of light years, letting scientists hear cosmic events. Observing these waves has opened a new window into extreme physics and the universe's evolution. It's incredible to think that space itself can ripple like a pond, carrying whispers of collisions that happened millions of years before humans even existed. Chapter 16. Some stars defy classification. Neutron stars, called magnetars, have magnetic fields trillions of times stronger than Earth's. They can flare violently, releasing bursts that affect entire galaxies. These stars demonstrate that nature can produce extremes far beyond human intuition. The physics governing them is exotic, involving superconductivity and nuclear density. Magnetars remind us that the cosmos isn't gentle or uniform. It is capable of creating conditions so extreme that even light and matter behave in ways we struggle to understand. Chapter 17. Some galaxies spin in reverse. Counter-rotating galaxies have stars or gas moving opposite to the main rotation. This happens when galaxies merge or interact, creating spectacularly chaotic dynamics. Such galaxies challenge astronomers' understanding of angular momentum and cosmic evolution. Observing them allows scientists to test models of galaxy formation and the role of dark matter. The universe is a place where motion can defy expectation, showing that even the largest structures have quirks and secrets waiting to be discovered. Chapter 18. Cosmic rays constantly bombard Earth. High-energy particles from supernovae and distant galaxies hit our atmosphere, creating showers of secondary particles. Some have energies millions of times higher than man-made accelerators. Studying them reveals clues about astrophysical phenomena, particle physics, and even the origins of matter in the universe. We are bathed in invisible radiation, connecting us to distant cataclysms. It's a subtle but constant reminder that Earth is part of a vast, energetic cosmos beyond our skies. Chapter 19. Exoplanets can have extreme orbits. Some swing dangerously close to their stars, then retreat in elongated paths, exposing them to scorching heat and freezing darkness alternately. Others orbit multiple stars, creating chaotic light patterns. These orbital oddities affect atmospheres, climate, and potential habitability. Observing them stretches our imagination about what a planet can be. The diversity shows that while Earth seems ordinary, the universe thrives on extremes, constantly challenging the limits of our expectations. Chapter 20. Some cosmic phenomena repeat mysteriously. Fast radio bursts are sudden, intense pulses of radio waves lasting milliseconds. Some repeat regularly, yet their origins remain uncertain. They could come from magnetars, exotic objects, or unknown astrophysical processes. Detecting them requires precise instruments and global collaboration. These bursts are fleeting, but carry enormous information about the intergalactic medium and extreme physics. They remind us that even in the briefest moments, the universe can be profoundly strange and revealing. Chapter 21. Some stars eject rings of gas as they die. Planetary nebulae glow in vibrant colors formed from shells of ionized gas expanding into space. These structures are not planets despite their name. They are the last breaths of dying stars. They create intricate shapes, bipolar lobes, spirals, and filaments, showing that even stellar death can be an art form. By studying these nebulae, scientists learn about stellar evolution, chemical enrichment, and the future of stars like our Sun. Chapter 22. Dark matter dominates the cosmos but remains invisible. It doesn't emit light, yet its gravity shapes galaxies, filaments, and cosmic structures. Without it, galaxies would fly apart. Astronomers detect it through gravitational effects on visible matter and lensing, where it bends light from distant objects. Dark matter is a silent architect, sculpting the universe while remaining unseen. Understanding it is key to solving the universe's biggest mysteries, proving that absence can be as influential as presence. Chapter 23. Some planets orbit binary stars, creating Tatooine skies with two suns. These circumbinary planets experience unique day-night cycles, seasons, and gravitational effects. Their existence challenges traditional models of planetary formation and shows that nature is far more inventive than fiction. Observing these worlds teaches scientists about orbital stability, star-planet interactions, and climate extremes. They are a reminder that the universe is full of surprises, where planets can thrive in environments that would seem impossible on Earth. Chapter 24. Cosmic dust shapes everything we see. Tiny particles floating in space scatter light, create nebulae, and serve as seeds for planets. Without dust, stars wouldn't form, and planets wouldn't exist. Observations with infrared telescopes reveal these hidden structures. Dust is both a creative and destructive force, influencing light, temperature, and chemistry in space. It's a reminder that even the smallest particles can have an outsized impact, building galaxies, stars, and worlds from mere grains of cosmic matter. Chapter 25. Supernova remnants are cosmic laboratories. After a star explodes, the shock wave interacts with surrounding gas, creating filaments and glowing clouds. These remnants are rich in elements essential for life: carbon, oxygen, iron. Studying them helps scientists understand nuclear processes and the life cycle of matter in galaxies. The remnants also accelerate cosmic rays, contributing to the energetic environment of space. They are spectacular, chaotic, and essential, showing that destruction and creation are inseparable in the universe. Chapter 26. Some stars travel at incredible speeds. Hypervelocity stars are ejected from galaxies, sometimes by black holes, moving faster than 1,000,000 miles per hour. They can escape their home galaxy entirely, wandering through intergalactic space. Studying their motion helps scientists map galactic centers, understand gravity, and even detect unseen black holes. These cosmic speedsters are reminders that the universe is dynamic, with objects propelled on extraordinary particles. Journeys far beyond what we experience on Earth. Chapter 27. Some planets have tilted axes that create extreme seasons. Uranus spins almost on its side, leading to decades of sunlight followed by decades of darkness at each pole. This axial tilt affects climate, winds, and even magnetic fields. Such unusual rotations challenge how we define planetary behavior. Studying these worlds teaches scientists about formation processes, collisions, and planetary dynamics. It's a vivid example of how planets can defy expectations, showing that even familiar worlds can behave in wildly unexpected ways. Chapter 28. Some black holes grow invisibly. Intermediate mass black holes are harder to detect than supermassive ones. They lurk quietly, pulling in matter slowly, emitting little radiation. Discovering them helps bridge the gap between stellar and supermassive black holes, solving questions about galaxy evolution. Their stealthy presence proves that even massive objects can remain hidden, shaping the universe silently while eluding detection. Sometimes, what we cannot see is as influential as what shines brightly. Chapter 29. Some stars collide and merge. When two stars in a binary system spiral together, they can create a more massive star, sometimes producing spectacular explosions or rare objects like blue stragglers. These events challenge the idea of stars as static points of light. The collisions influence star cluster dynamics, chemical composition, and cosmic evolution. Observing these mergers shows that even stars can have dramatic life stories, blending physics, gravity, and chance into dazzling cosmic outcomes. Chapter 30. Some galaxies host strange cores. Active galactic nuclei are supermassive black holes devouring matter at furious rates, emitting light that outshines the galaxy itself. Jets of plasma shoot out at near light speed, affecting nearby stars and gas clouds. Studying them reveals extreme physics, magnetic fields, and galaxy evolution. These cores demonstrate that galaxies are not just collections of stars. They are dynamic ecosystems where gravity, energy, and matter interact in dramatic and often violent ways. Chapter 31. Some stars explode silently. Failed supernova occur when massive stars collapse directly into black holes without a visible explosion. The star simply disappears, leaving only gravity as a clue. Astronomers detect these events by monitoring stars over years, noting those that vanish. Without fanfare, this phenomenon challenges our understanding of stellar death and shows that cosmic endings can be quiet yet monumental. Even absence can tell a powerful story in the universe. Chapter 32. Some planets are volcanic giants. Io, a moon of Jupiter, is the most volcanically active body in the solar system. Its surface constantly reshapes with lava flows, geysers, and sulfuric plumes. This activity is powered by tidal forces from Jupiter and neighboring moons, demonstrating how gravity can create dynamic worlds. Studying Io helps scientists understand planetary geology, tidal heating, and extreme environments beyond Earth. Its restless surface is a reminder that some worlds never sleep. Chapter 33. Some stars are surrounded by rings of dust. These circumstellar disks are birthplaces for planets, forming from gas and dust orbiting young stars. Over millions of years, particles collide, stick, and remain, and grow into planets and moons. Observing these disks helps scientists understand how solar systems form and evolve. These dusty rings are evidence that creation is messy, slow, and spectacular, turning tiny grains into worlds that may one day host life. Chapter 34. Some galaxies hide in plain sight. Ultra-diffuse galaxies are as large as the Milky Way, but contain only a fraction of its stars. They are nearly invisible against the cosmic backdrop. Detectable mostly through gravitational effects, These ghostly galaxies challenge ideas about galaxy formation and dark matter distribution. Despite their faintness, they shape the universe in subtle ways, proving that size and visibility are not always linked in cosmic significance. Chapter 35. Some stars flicker like neon lights. Variable stars change brightness due to pulsations, eruptions, or interactions with companions. Observing them allows astronomers to measure distances, track stellar evolution, and study exotic physics. Each flicker is a heartbeat of the cosmos, revealing inner mechanisms that light cannot conceal. These stars remind us that even points of light in the night sky are dynamic, living laboratories teaching us about time, energy, and motion on cosmic scales. Chapter 36. Some black holes spin at near light speed. These rapid rotations drag space-time itself, creating warped regions around them known as ergospheres. Matter entering these zones can extract energy from the black hole, powering jets and radiation. Studying them tests Einstein's theories and extreme physics. The universe shows that rotation can amplify power, producing phenomena that defy intuition and illustrate that gravity is not just a pull. It can twist reality itself. Chapter 37. Some stars explode multiple times. Luminous blue variables can erupt violently, shedding huge amounts of mass before their final supernova. Eta Carinae is a famous example, with eruptions visible from Earth. These stars demonstrate that death can be a process, not a single event. Their unpredictable behavior teaches scientists about stellar stability, mass loss, and the role of massive stars in enriching the galaxy with heavy elements. Even the brightest stars have a volatile side. Chapter 38. Some planets have rings wider than their stars. Saturn's rings are spectacular, but some exoplanets may host debris disks spanning millions of kilometers. These rings can block starlight, create shadows, and evolve over time. Observing them reveals planet formation, processes, collisions, and gravitational interactions. Rings are both beautiful and scientific laboratories, proving that planetary systems are sculpted not just by planets, but by the intricate dance of dust, rocks, and ice. Chapter 39. Some galaxies cannibalize others. Larger galaxies pull in smaller ones, stripping stars, gas, and dust. These mergers trigger starbursts, black hole activity, and dramatic structural changes. The Milky Way has consumed smaller galaxies in the past and will eventually merge with Andromeda. Galactic cannibalism shows that cosmic growth is violent, yet essential, building larger structures from smaller ones and reshaping the universe over billions of years. Chapter 40. Some stars survive supernovae as neutron stars. These dense remnants pack solar masses into a city-sized sphere, creating extreme gravity, magnetic fields, and radiation. Pulsars, a type of neutron star, emit beams that sweep space like cosmic lighthouses. Studying them helps scientists probe nuclear matter, relativity, and stellar evolution. Even after a star's death, it can continue to influence the cosmos, spinning, emitting, and reminding us that endings can be just another beginning. Chapter 41. Some stars live in pairs so close they share matter. These contact binaries transfer gas from one star to the other, changing mass, rotation, and brightness. This intimate dance can trigger outbursts, novae, or even mergers. Studying them helps scientists understand stellar evolution, mass transfer, and the origins of exotic objects like neutron star binaries. The universe shows that even stars can have complicated relationships, proving that cosmic interactions are sometimes as dramatic as human ones. Chapter 42. Some black holes create cosmic fireworks. When matter falls in, it forms an accretion disk that heats up, emitting X-rays and gamma rays. Powerful jets shoot out along the poles at nearly the speed of light. These jets can extend across entire galaxies, shaping star formation and interstellar gas. Observing them reveals extreme physics, magnetic fields, and energy flows impossible to replicate on Earth. Black holes may seem like voids, but they are engines of phenomenal cosmic activity. Chapter 43. Some stars rotate faster than a tornado. Achernar spins so fast it bulges at the equator, flattening at the poles. Rapid rotation affects temperature, gravity, and mass loss. Studying such stars helps scientists test stellar structure models and understand angular momentum's role in evolution. Fast-spinning stars show that motion can reshape matter, creating unique environments that challenge intuition. Even seemingly simple spheres of plasma can have complex, extreme behaviors driven by rotation. Chapter 44. Some planets orbit stars that flare unpredictably. Red dwarfs, the most common stars in our galaxy, unleash massive stellar flares capable of stripping atmospheres from close planets. This affects potential habitability and climate stability. Observing these flares teaches scientists about stellar magnetic fields, planetary protection, and space weather on cosmic scales. It's a reminder that not all stars are gentle lights. Some are volatile and dangerous, shaping the destiny of worlds around them. Chapter 45. Some galaxies appear ghostly. Low-surface brightness galaxies are faint, often missed by telescopes, yet they contain dark matter and sparse stars. They challenge assumptions about galaxy formation and evolution. Detecting them requires sensitive instruments, revealing that the universe is full of hidden structures. Their subtle presence shows that cosmic significance isn't always visible, proving that even faint objects can play major roles in shaping the universe. Chapter 46. Some stars have extreme magnetic fields. Magnetars pack trillions of times Earth's magnetic strength, capable of disrupting electronics from light years away. They're telescopes, yet they contain dark matter and sparse stars. They challenge assumptions about galaxy formation and evolution. Detecting them requires sensitive instruments, revealing that the universe is full of hidden structures. Their subtle presence shows that cosmic significance isn't always visible, proving that even faint objects can play major roles in shaping the universe. Chapter 46. Some stars have extreme magnetic fields. Magnetars pack trillions of times Earth's magnetic strength, capable of disrupting electronics from light years away. Interpret galactic evolution. Observing these hidden structures allows scientists to understand star formation, galaxy growth, and the life cycle of matter. Even in obscurity, the universe remains brilliantly active. Chapter 49. Some stars are cannibals. In close binaries, one star can strip material from its companion, creating novae or even X-ray binaries. These events emit radiation detectable across galaxies. Mass transfer alters stellar evolution and can trigger exotic phenomena like pulsars or black holes. Studying these interactions teaches about gravity, nuclear fusion, and the life cycle of stars in extreme conditions. Cosmic cannibalism proves that even stars participate in complex, sometimes violent relationships that shape the universe. Chapter 50. Some cosmic structures repeat across scales. Fractals appear in galaxy distributions, nebulae, and even star formation patterns. This self-similarity suggests universal processes shaping matter and energy. Studying these patterns helps scientists understand turbulence, gravitational clustering, and the behavior of cosmic gas. Nature repeats itself in strange ways, showing that even chaos has underlying order. Recognizing these patterns allows astronomers to predict and interpret phenomena across immense scales in the universe. Chapter 51. Some stars create rings as they die. Supernova can eject layers of gas in concentric shells, glowing as they expand. These rings reveal the star's history, shedding light on mass loss and stellar winds. Observing them helps scientists trace chemical enrichment in galaxies and the processes leading to compact remnants like neutron stars. Even in death, stars sculpt breathtaking structures, leaving cosmic fingerprints that astronomers can study for millions of years. Chapter 52. Some black holes are invisible architects. Intermediate mass black holes lurk quietly in star clusters, affecting star motions and shaping cluster evolution without emitting detectable light. Discovering them requires careful observation of stellar orbits and gravitational effects. They bridge the gap between stellar mass and supermassive black holes, revealing how cosmic giants grow. Even unseen, they influence structure and dynamics, proving that absence doesn't mean insignificance in the universe. Chapter 53. Some planets are extreme infernos. Hot Jupiters orbit dangerously close to their stars, with temperatures so high that metals can vaporize. Their atmospheres are blown away by stellar radiation, forming tails like comets. Studying these worlds helps scientists understand atmospheric physics, planet-star interactions, and the limits of planetary survival. These scorching giants prove that proximity to a star can transform planets into extreme, alien environments far beyond earthly experience. Chapter 54. Some stars flicker unpredictably. Pulsating variable stars expand and contract, changing brightness over days or weeks. These rhythms act as cosmic rulers, letting astronomers measure distances across galaxies. Observing them refines our understanding of the universe's scale, age, and structure. Even subtle light variations encode valuable information. The cosmos communicates in patterns, proving that small changes can reveal immense truths about space and time. Chapter 55. Some galaxies spin backward. Counter-rotating stars and gas create internal chaos, often caused by mergers or accretions. These galaxies challenge models of angular momentum and evolution, showing that cosmic dynamics can be surprisingly complex. Studying them helps scientists understand how galaxies form, interact, and grow. Even on the grandest scales, motion can defy expectation, proving that the universe doesn't always follow simple rules. Chapter 56. Some stars live only briefly. Massive stars burn fuel rapidly, exhausting it in mere millions of years before exploding as supernovae. Despite their short lives, they forge heavy elements and enrich galaxies. Their explosions trigger star formation and shape cosmic structure. Even fleeting existence can leave permanent marks on the universe. These short-lived giants remind us that intensity and impact often matter more than longevity in the cosmos. Chapter 57. Some planets wander alone. Rogue planets drift through space without a host star, cold and dark. Their existence challenges traditional ideas of planetary systems. Detected mainly through gravitational microlensing, they may number in the billions. These lonely worlds show that the universe allows independence on cosmic scales, with planets traveling across galaxies in eternal night, shaping our understanding of planetary diversity. Chapter 58. Some black holes spin wildly. Rapid rotation twists space-time, creating warped regions called ergospheres. Matter entering these zones can extract energy, powering jets and high-energy radiation. Studying them tests general relativity under extreme conditions. These cosmic. So, whirlpools prove that gravity can twist reality itself, producing phenomena unimaginable on Earth. Black holes are not only destructive, they are engines of extreme physics. Chapter 59. Some stars merge in spectacular ways. Binary stars spiraling together can produce massive objects or trigger explosive outbursts. These events alter the star's evolution, chemical output, and surroundings. Studying mergers teaches scientists about mass transfer, stellar collisions, and the creation of exotic remnants like neutron stars. Cosmic collisions reveal that even stars can have dramatic, intertwined life stories, with endings as thrilling as their beginnings. Chapter 60. Some galaxies hide active cores. Supermassive black holes at their centers can emit more energy than the entire galaxy. Accretion disks and jets shape star formation and interstellar gas, influencing galaxy evolution. Observing active galactic nuclei provides insight into extreme physics, magnetic fields, and cosmic energy flow. These dynamic centers prove that galaxies are not static collections of stars. They are ecosystems of matter, energy, and gravity interacting on grand scales. Chapter 61. Some stars wobble mysteriously. Binary companions or hidden planets can cause subtle shifts. But some stars, like Tabby's star, dim irregularly without a clear cause. Dust clouds, comet swarms, or unusual stellar activity may be responsible. Observing these flickers challenges astronomers to rethink stellar behavior and light patterns. Even small, unexplained variations in brightness can reveal complex cosmic processes, showing that the universe often hides secrets in plain sight. Chapter 62. Some cosmic voids are enormous. These vast empty regions span hundreds of millions of light years, containing few galaxies. Their existence shapes the cosmic web, pushing matter into filaments and clusters. Studying voids helps scientists understand dark energy, expansion, and large-scale structure. Even emptiness exerts influence, proving that the universe's fabric is defined not only by what exists, but also by what doesn't. Cosmic nothingness can have profound effects. Chapter 63. Some stars eject jets at near light speed. Young stellar objects shoot out plasma in narrow beams as they form, shaping surrounding gas and dust. These jets reveal the physics of star formation, magnetic fields, and angular momentum transfer. They carve cavities in nebulae, sculpting the birthplaces of future stars. Even in their infancy, stars demonstrate power and structure, showing that creation in the cosmos can be both chaotic and beautiful. Chapter 64. Some exoplanets defy imagination. Diamond planets may have carbon-rich cores under extreme pressure, turning into crystalline structures. Hot Jupiters blaze near their stars, while tidally locked worlds endure eternal day or night. Studying these planets expands our understanding of planetary physics, formation, and diversity. The universe shows that planets are far stranger than Earth-based intuition allows, with endless variations in composition, climate, and orbit. Chapter 65. Some galaxies collide spectacularly. When two galaxies meet, gravitational forces fling stars, gas, and dust, triggering bursts of star formation. These cosmic interactions can create tidal tails, loops, and irregular shapes. Mergers drive evolution, feeding supermassive black holes and reshaping structure. Observing them reveals how gravity molds the universe over billions of years. Even the largest cosmic structures are not static. They dance, clash, and create beauty in motion. Chapter 66. Some stars have extreme magnetic fields. Magnetars pack trillions of times Earth's field strength, causing bursts of gamma rays and X-rays detectable across galaxies. These stars test physics under unimaginable conditions, revealing behavior of matter at nuclear density. Magnetars prove that the universe can amplify forces to extremes far beyond human experience. Studying them teaches how magnetism, rotation, and gravity combine in the most violent cosmic laboratories. Chapter 67. Some planets orbit multiple stars. Circumbinary planets circle two suns, creating unique day-night cycles and seasons. Others experience gravitational tugs from multiple stars, affecting orbit stability. Observing these systems reveals how planetary formation adapts to complex environments. The universe shows that life, if possible, could exist under conditions far stranger than earthly norms. Multiple star systems expand imagination and understanding of planetary possibilities. Chapter 68. Some stars pulsate rhythmically. Cepheid variables expand and contract, producing light patterns used to measure cosmic distances. These stellar metronomes help map galaxies, calculate expansion rates, and refine our understanding of the universe's age. Even small brightness variations hold crucial information. The universe communicates through light, proving that patterns, repetition, and timing are tools for exploring cosmic scale. Chapter 69. Some supernovae leave spectacular remnants. Explosions create glowing shells, filaments, and shockwaves rich in heavy elements. These remnants seed galaxies with materials needed for planets and life. They also accelerate cosmic rays, energizing interstellar space. Studying them reveals nuclear physics, stellar life cycles, and the interconnectedness of matter. Destruction and creation are inseparable in the universe, with each explosion leaving a legacy that endures for millions of years. Chapter 70. Some stars travel at incredible speeds. Hypervelocity stars are ejected from galaxies, often by black hole interactions, moving fast enough to escape their home entirely. Their motion maps galactic centers and gravitational effects. These cosmic speedsters demonstrate that the universe is dynamic, with stars propelled on extraordinary journeys. Even solitary travelers carry information about their origins, showing that movement through space can be as revealing as light or matter. Chapter 71. Some stars are born in clusters, tightly packed in stellar nurseries. These dense environments force stars to interact, exchanging mass or even merging. Gravity sculpts these clusters, influencing stellar evolution and planet formation. Observing them reveals how stars grow, compete, and sometimes collide. The universe shows that even in birth, stars are social and dynamic, shaping each other's destinies in ways that echo across millions of years. Chapter 72. Some black holes flare unpredictably. When gas falls into a supermassive black hole, it can ignite bursts of X-rays and radiation. These outbursts affect nearby stars and gas, sometimes triggering new star formation. Monitoring these flares helps scientists understand accretion physics and extreme gravity. Even objects that seem silent can suddenly unleash energy rivaling entire galaxies, showing that cosmic power can be hidden until conditions align perfectly. Chapter 73. Some planets are icy giants. Uranus and Neptune have thick atmospheres of hydrogen, helium, and methane, producing extreme winds and magnetic fields. Their interiors may contain exotic ices under high pressure. Studying them informs planetary physics, formation, and magnetic field generation. These distant worlds show that planets can be dramatically different from Earth, with environments of intense cold, storms, and invisible forces shaping their landscapes. Chapter 74. Some stars explode multiple times. Luminous blue Chapter 75. Some galaxies spin with irregular motion. Stars or gas moving in opposite directions create counter-rotating systems. These configurations result from mergers or accretion events, challenging models of angular momentum. Observing them helps scientists understand galaxy formation and evolution. Even massive systems can behave unpredictably, proving that cosmic structures are shaped not just by gravity, but by complex histories of interaction. Chapter 76. Some stars collapse silently. Failed supernovae occur when massive stars form black holes without visible explosions. Astronomers detect them by monitoring stars that disappear over time. These silent deaths challenge traditional models and show that cosmic endings can be subtle yet significant. Even when a star vanishes without spectacle, it leaves a profound imprint on the universe's structure and evolution. Chapter 77. Some planets are stripped bare by their stars. Extreme radiation from hot stars can remove atmospheres entirely, leaving rocky cores exposed. Observing these Chthonian planets reveals the limits of planetary survival and the destructive influence of stellar proximity. The universe shows that planets are fragile, shaped and sometimes destroyed by forces far beyond human experience. Even survival requires a delicate cosmic balance. Chapter 78. Some neutron stars glitch. Their rapid rotation sometimes speeds up suddenly, releasing bursts of energy. These glitches reveal the interior physics of ultra-dense matter, where nuclei behave in exotic ways. Studying them tests models of matter under extreme conditions. Even small shifts in rotation provide a window into forces and densities impossible to replicate on Earth, showing that cosmic behavior can be both subtle and profound. Chapter 79. Some galaxies hide in shadows. Dust-obscured galaxies emit primarily in infrared, concealing star-forming activity from visible light telescopes. Observing them unveils hidden stellar nurseries and galactic growth. Dust both hides and highlights, teaching scientists about formation, evolution, and cosmic energy distribution. Even obscured objects can be dynamic, reminding us that visibility isn't always linked to importance. Chapter 80. Some stars eject material in polar jets. Young stars funnel gas and plasma along magnetic axes, shaping surrounding clouds. These jets reveal angular momentum transfer and magnetic field structure. They influence star formation, carving paths through nebulae. Even in early life, stars are sculptors, shaping their environment through energetic outflows. Cosmic creation is messy, energetic, and remarkably beautiful. Chapter 81. Some stars are loners, drifting through space without companions. Solitary stars live quiet lives, unaffected by binary interactions, yet their evolution still produces heavy elements through supernovae. Studying them helps scientists understand standard stellar life cycles and chemical enrichment. Even alone, stars influence galaxies, seeding space with the building blocks of planets and life. Solitude doesn't mean insignificance in the cosmic story. Chapter 82. Some black holes feast slowly. Not all devour matter violently. Some accrete gas gradually, emitting faint radiation. These hidden giants influence surrounding stars and gas quietly, shaping star cluster dynamics. Detecting them requires careful observation of stellar motion and X-ray emissions. Even silent black holes play a crucial role in cosmic evolution, proving that impact isn't always measured by brightness or spectacle. Chapter 83. Some planets orbit in extreme ways. Highly eccentric orbits stretch their year into drastic swings of heat and cold. Some tidally locked worlds show one face to their star constantly, creating permanent day and night sides. Studying these planets informs scientists about orbital mechanics, climate extremes, and potential habitability. The universe demonstrates that planetary diversity is far broader than Earth-based expectations. Chapter 84. Some stars pulse with precision. Cepheid variables expand and contract, producing predictable light patterns used as cosmic rulers. Their rhythms allow measurement of galaxy distances and expansion rates. Even tiny brightness changes encode essential information about scale and age. The universe communicates in patterns, proving that observation of light reveals secrets across billions of light years. Chapter 85. Some galaxies collide gracefully. Interacting galaxies create tidal tails, loops, and bursts of star formation. Gravity sculpts stars and gas, feeding black holes and reshaping structure. Observing these events reveals how large-scale cosmic evolution occurs. Even violent interactions produce beauty, showing that chaos and creation coexist in the universe. Chapter 86. Some stars harbor extreme magnetism. Magmetars emit bursts of gamma rays and X-rays, testing physics at nuclear densities. Their magnetic fields can distort space-time locally, and their energy output rivals entire galaxies. Studying them reveals behavior of matter under unimaginable forces. Magnetars demonstrate that nature can amplify power beyond human comprehension. Chapter 87. Some planets orbit multiple suns. Circumbinary systems produce complex seasons, shadows, and gravitational effects. Their study informs models of planetary formation and orbital stability. These worlds challenge Earth-centric assumptions, showing that the universe is imaginative in planetary design. Life, if possible, must adapt to conditions far stranger than we experience. Chapter 88. Some stars exhibit sudden brightness changes. Variable stars, caused by pulsations or companion interactions, act as cosmic laboratories. Observing them teaches about stellar structure, composition. Chapter 89. Some supernovae leave intricate remnants. Expanding shells, filaments, and shockwaves distribute heavy elements across space, enabling planet and life formation. These remnants also accelerate cosmic rays, energizing the galaxy. Studying them provides insight into nuclear processes and matter recycling. Destruction and creation are intertwined, leaving lasting marks in the cosmos. Chapter 90. Some stars travel at hypervelocity. Ejected from galactic centers, these stars move fast enough to escape their galaxies entirely. Tracking their motion helps map gravity, galactic interactions, and black hole effects. Even solitary travelers carry clues about cosmic history, showing that movement through space can reveal as much as light or matter itself. Chapter 91. Some stars are born in tight clusters, where gravitational interactions are intense. Stars can exchange mass, collide, or even merge in these crowded nurseries. These interactions shape stellar evolution and future planetary systems. Observing them provides insight into the earliest stages of star life. Even in infancy, stars influence each other dramatically, proving that birthplaces can be as dynamic as the stars themselves. Chapter 92. Some black holes emit powerful jets. As matter spirals into supermassive black holes, it heats up and shoots plasma at nearly light speed along magnetic poles. These jets can extend across thousands of light years, affecting surrounding gas and star formation. Observing them allows scientists to study extreme physics, energy transport, and galaxy evolution. Black holes are not just absorbers of matter, they can sculpt galaxies from afar. Chapter 93. Some planets are extreme cold worlds. Rogue planets, drifting without a star, experience eternal darkness and freezing temperatures. Some may retain internal heat from formation or radioactive decay, but most remain frozen and invisible. Detecting them requires sensitive gravitational techniques. Their existence shows that the universe is home to lonely, extreme worlds that challenge traditional definitions of a planet. Chapter 94. Some stars rotate incredibly fast. Rapidly spinning stars bulge at the equator, affecting temperature, gravity, and lifespan. Spin can also drive strong stellar winds and influence element distribution. Studying these stars tests theories of angular momentum and stellar structure. Even simple spheres of plasma can display extreme behaviors, proving that motion dramatically shapes cosmic objects. Chapter 95. Some galaxies hide in dust. Infrared observations reveal star-forming regions obscured in visible light. These stellar nurseries glow brightly in infrared, showing active creation behind the veil. Dust both conceals and highlights, teaching scientists about galactic evolution and energy distribution. Hidden structures remind us that the universe often reveals its secrets only when observed carefully. Chapter 96. Some stars collapse into neutron stars silently. These ultra-dense remnants pack solar masses into city-sized spheres with extreme gravity and magnetic fields. Pulsars emit beams like cosmic lighthouses, and studying them reveals physics at nuclear densities. Even after death, stars continue to influence the cosmos, spinning and emitting energy across vast distances. Chapter 97. Some planets have tilted axes causing extreme seasons. Uranus spins almost on its side, creating decades-long periods of sunlight and darkness at its poles. Tilt affects climate, winds, and magnetic fields. Studying axial tilt helps understand planetary formation and dynamics. The universe proves that planetary behavior can defy expectation, creating environments far stranger than Earth. Chapter 98. Some galaxies cannibalize smaller neighbors. Large galaxies pull in stars, gas, and dust, triggering starbursts and feeding central black holes. These mergers reshape structure and evolution over billions of years. Observing them shows that cosmic growth is often violent, yet essential, building the universe from smaller components into larger, more complex structures. Chapter 99. Some stars emit sudden bursts of energy. Magnetars produce soft gamma-ray repeaters detectable across galaxies. These extreme events test physics under conditions impossible on Earth. Their magnetic fields twist space-time, influencing nearby matter and light. Even brief cosmic flashes carry immense energy and information, reminding us that the universe is both violent and awe-inspiring. Chapter 100. Some cosmic patterns repeat across scales. Fractals appear in galaxy distributions, nebulae, and star formation, showing self-similarity across vast distances. These patterns help scientists understand gravitational clustering, turbulence, and cosmic evolution. Even in chaos, there is order. The universe communicates through repeated structures, proving that underlying rules shape everything from tiny particles to the grandest galaxies. That's 100 strange wonders of the observable universe. From the tiniest dust grains to supermassive black holes, the cosmos never stops surprising us. Keep looking up. There's always more to discover.